Welcome to another Snow Day video for Chemistry 121. The following is the assignment for February 7th. As many of you know, class has been canceled again due to snow. And today's assignment is to watch the following video about drawing Lewis structures, or electron dot symbols. I've received a lot of questions from students about when to turn in the paper assignments for this week. My advice is relax. Don't freak out. All of our assignments this week are due at the beginning of our next class period, which will ideally be Thursday, February 9th. If school is canceled again due to snow, we'll just turn in our assignments on the following class period, so whenever we see each other next. I do have a few notes about the Unit 2 quiz, which should be on Thursday of this week, February 9th. The following topics were originally going to be on the Unit 2 quiz, but because we haven't had traditional lecture, covalent nomenclature, Lewis structures, and VSEPR will not be on the quiz. Finally, we will be having lab this week, pending snow, so ideally I'll see you for Lab 5 on Wednesday for Section A or Friday for Section B. Lewis structures, or electron dot symbols, are what we draw for covalent compounds. As we know already, covalent compounds that have atoms share their electrons between the atoms. They share electrons to become more stable, and ideally each atom will have a total of 8 electrons after the electrons have been shared, or they fulfill the octet rule. Drawing a Lewis structure will allow us to show how the atoms are connected together and how those atoms share electrons. How many, specifically. You should use the following rules when drawing Lewis structures. Begin by drawing the Lewis structures for the individual atoms. As you recall, the Lewis structure for an individual atom involves the element symbol and then the valence electrons drawn around the element symbol in either single electrons or pairs. Next, you should share any unpaired electrons by circling the pairs between the atoms, then erasing those circle pairs and drawing each pair as a line or a covalent bond. Finally, you should be sure to keep the lone pairs of electrons that were not shared as they were on the individual atoms for the final compound. Here's an example. 2 fluorine atoms only have 7 valence electrons. They want 8 to have a stable electron configuration. The single electrons that are on each fluorine atom's Lewis structure are the ones that will be shared. Each fluorine will share 1 electron, creating 1 covalent bond. The bonding pair will erase and draws a single line to represent the covalent bond of the fluorine molecule. Some important notes. The number of electrons or valence electrons that are in the individual atoms before you draw the Lewis structure should be equal to the number of electrons that are in your final compound. We're going to follow the law of conservation of mass and not add any electrons or lose any electrons. There are 3 types of covalent bonds that we'll draw with our electron dot symbols, or Lewis structures. A single bond is 1 line and contains 2 electrons that are shared, or 1 pair of shared electrons. A double bond exists between 2 atoms if 4 electrons are shared, or 2 pairs of electrons are shared. We represent a double bond as 2 lines. Finally, a triple bond, as you might expect, contains 6 shared electrons, or 3 pairs. Those 3 pairs of shared electrons we will represent with 3 single lines. Okay. I'm going to adjust our viewpoint so I can show you how to draw some of our structures. So we're going to begin by drawing a very simple structure for hydrogen. Hydrogen is one of our diatomic elements. I'm going to begin by drawing the individual Lewis structures for the 2 atoms. Each hydrogen has 1 valence electron. I can count those up and say that I should have 2 total valence electrons before and after I draw my Lewis structure. Each single electron can be shared. So here's 1 pair of shared electrons. I'm then going to redraw my structure. So instead of circle electrons, each pair is represented by a line. This line right here contains 2 electrons, or it is called a single bond. A double bond exists between two atoms of oxygen in the oxygen molecule. I'll begin by drawing the individual Lewis structures for the oxygen atom. There are 6 valence electrons, or 1, 2, 3, 4, 5, 6, around each oxygen atom. I like to draw my Lewis structures so the individual electrons, or the electrons that will be shared, are facing the other atom. So each oxygen atom can share 2 electrons. These paired electrons over here will never be shared. I'm then going to draw some circles around the shared electrons. Okay. So if I were to count the number of valence electrons around each atom, I should now have 8. I have 1, 2, 3, 4, 5, 6, 7, 8 around this oxygen atom, and 1, 2, 3, 4, 5, 6, 7, 8 around this one. Each individual oxygen atom came with 6 valence electrons, so there should be a total of 12. I'm then going to redraw my Lewis structure. Instead of circled electrons, I'm going to draw each pair as a line. Since 4 electrons are being shared, it's going to be a double bond. The unshared electrons still exist on the oxygen atoms, so I like to draw them in. This is the Lewis structure for the oxygen molecule and its double bond. Let's draw one more with a triple bond. Nitrogen is going to form a triple bond. I'll begin by drawing each individual nitrogen atom. Each nitrogen atom has 5 valence electrons, 1, 2, 3, 4, 5. And I have 5 on this nitrogen also, bringing my total up to 10 valence electrons. Each of these single electrons can be shared, so I see that each nitrogen has 3 electrons to share. Then I'm going to redraw my structure. Instead of circled electrons, I'm going to draw a triple bond. 3 pairs, 3 lines. These unshared electrons are still important, so I'm going to draw them in. This is a structure of nitrogen molecule, which contains a triple bond, or 6 shared electrons. I'm now going to show you some Lewis structures for compounds. If you'd like to pause the video before I draw each one just to practice, that would be an excellent way of challenging yourself. So first we're going to draw a methane molecule, or CH4. I'll begin by drawing the individual atoms and their Lewis structures. I have 1 carbon atom. It has 4 valence electrons. Because it has 4 unpaired electrons, I'm going to put it in the middle of my structure since it can make the most bonds. I then have 4 hydrogens. And each hydrogen, since it has 1 single electron, can make 1 bond. So I'm going to surround the carbon atom with 4 hydrogens. In total, I have 8 valence electrons, which is how many I should have at the very end. I'm then going to circle the shared electrons. Each hydrogen will share 1 electron with carbon, and carbon will share 1 electron with each of the hydrogen atoms. This carbon should now be able to count 8 electrons as part of its octet. 1, 2, 3, 4, 5, 6, 7, 8. Carbon now has 8 electrons and is very stable. Hydrogen and other smaller atoms only need 2 electrons to be stable. We call that a duet, and each hydrogen can claim 2 electrons. I'm then going to redraw my structure, where instead of circled electrons, I have 1 line for each shared pair. This is the Lewis structure for methane, or CH4. We have 1 carbon in the middle and 4 single bonds leading to 4 hydrogens. Next, we're going to draw carbon dioxide. Carbon dioxide has 1 carbon and 2 oxygen atoms. I'm going to begin with carbon. I know it has 4 valence electrons and can make 4 bonds, so I'm going to put it in the middle since 4 is the largest number of bonds that will be made. I'm then going to draw an oxygen atom on each side with its 6 valence electrons, 2 unpaired, so this oxygen atom can share 2 electrons with this carbon. On the other side, I'm going to draw another oxygen atom with its 6 valence electrons. We have 6 electrons here, 6 electrons here for 12, plus 4 more gives us 16 total. Now I'm going to share some electrons. So I know carbon can make 4 bonds, and this carbon's going to make 2 bonds with this oxygen atom. and 2 bonds with this oxygen also. All of the single electrons have been paired up, and we can count electrons around each atom, and we should have 8 total. I'm then going to redraw my molecule, where instead of circled electrons, I'll have a double bond between each carbon and oxygen. Remember, the unshared electrons are still part of the structure, so I have 2 pairs of unshared electrons on each oxygen atom. This is the Lewis structure for carbon dioxide. Carbon in the middle, a double bond with this oxygen, and a double bond with this oxygen. And now I'm going to draw nitrogen trifluoride. There'll be a lot of electrons kicking around, so I want to keep track of them all. I'll begin by drawing my nitrogen. I know nitrogen has 5 valence electrons, and because it has 3 single electrons, it can make 3 bonds, and coincidentally, there are 3 fluorine atoms. Each fluorine has 7 valence electrons, and I'm going to put the single electron of each fluorine atom towards the nitrogen. Okay, so this nitrogen has 5 valence electrons, each fluorine has 7, for a total of 26. Okay. Now the single electrons I can share. Each fluorine atom will share 1 electron with nitrogen, and nitrogen has 3 single electrons it can share with the fluorine atoms. Each atom now has 8 valence electrons, or we've fulfilled the octet. I'm going to redraw my structure with nitrogen in the middle and some single bonds leading to each fluorine atom. I'm not done until I've drawn every pair of electrons that are around all the atoms to keep my octet intact. So each fluorine will have 6 valence electrons unshared, and nitrogen will have 1 pair of unshared electrons. Okay. This is my Lewis structure for nitrogen trifluoride. Nitrogen in the middle, 3 single bonds leading to 3 fluorine atoms. Let's draw one final structure. Silicon disulfide. This is similar to the way a water molecule will look, if you want to practice that later. I'll draw silicone first. Silicone has 4 valence electrons, 1, 2, 3, 4. And then I have sulfur, 2 of them, and each sulfur atom has 6 electrons. Okay. So similar to our carbon dioxide, we have an atom in the middle with 4 unpaired electrons, and 2 atoms on the side with 6 valence electrons. So when I share, I'm going to share again, but this time I'm going to try and simplify my life a little bit by, instead of circling, I'm going to draw lines in between the unpaired electrons. So you can circle or draw lines. I'm going to redraw my structure with silicone in the middle, some double bonds to sulfur, and these unshared electrons on the sulfur atoms. Okay. So we had 4 valence electrons around the silicone, 6 around each sulfur, for a total of 16 valence electrons. I'm going to draw one more popular one on the back. Change my mind. We're going to draw water up here at the top. Water is a very common compound. It makes up most of your body and most of the earth. I'm going to draw an oxygen atom first. Oxygen, as you recall, has 6 valence electrons, and hydrogen has 1. I'm going to circle the single electrons to share between the oxygen and hydrogen, and then redraw my structure. So this is the Lewis structure for a water molecule. One of the great things about Lewis structures is it doesn't show you the shape of the molecule, it just shows you how the atoms are connected. So you can draw your water molecule like this, or you can draw it with your oxygen up here, a hydrogen over here, a hydrogen over here, and 2 sets of unshared electrons on the hydrogen. Both of these are Lewis structures for water. They both have single bonds to hydrogen and 2 pairs of unshared electrons on the oxygen atoms. Hopefully the snow goes away soon, or for many of you, you may be hoping it sticks around for longer. But either way, keep checking Canvas for more videos if we have class cancellation, or I'll see you either in lab this week or in lecture.